Yeah, hello everyone. My name is Kacper. I come from Poland, so not that far away. I've been loving this city for a quite long time, and it's always a pleasure to come back to Budapest. I love the city, really. And I'm here today to talk about a little bit about security, and to talk about security in the context of JavaScript applications. Every once in a while, the big news break out that some of the leading companies got hacked, right? Millions of credit card details, personal data got leaked, people get anxious, people get angry, the reputation of the companies got undermined. And if you look closely, it seems that there are some technology giants that get those kind of problems. And for me, it can only mean one thing, that security is really, really hard. And I don't know if you've heard about this product. They got hacked like in 2011. And they lost some credit card details, so the hackers could use them to use your credit card to buy different things. And it's estimated that Sony lost $171 million as a consequence, right? Because they had to first fix the issue. The PlayStation Network was down for some time, and then they have to pay the insurances, like make refunds and stuff like that. So it's really, really important to know that your company can lose a lot of money, not to mention reputation, right? But you can lose a lot of money if you get security wrong. But the things I'm talking about are mostly backend related. Probably most of us here are front-end developers. There are probably some backend developers, but I'm going to focus on front-end right now. And we usually don't deal with databases, with user data, because we do front-end, right? And we are safe. So we shouldn't be talking about security. And it turns out that, nope, we aren't safe, we aren't secure. And does any one of you know this guy? No. So cool, because it's a very, very cool story. His name is Sami Kamkar, and he wrote the fastest spreading virus ever using JavaScript. Yeah, really. That's the Wikipedia page of this. And he used JavaScript to write a virus that spread on MySpace. MySpace was like Facebook back then. Sorry for the images, I couldn't find any better. But the virus wasn't really that harmful. It just sent a friend invitation to many different people. It just sent Sami invitation from many different people and just posted some random post like Sami is awesome or something like this. And he ended up having this many pages of friend requests. So that was pretty. The virus went crazy, went really viral, and as a consequence, he went to jail. They made him pay some money as a compensation, and he also had to do some public service. So yeah, that was treated really seriously. And by the way, if you don't know Sami, you should definitely check out his GitHub page, because he's done security research. I don't approve the thing he has done with MySpace, but still, he's now a security researcher, and he does really cool stuff. And one might ask, how was Sami able to get this virus running? And he used the technique called Crosssite scripting. And probably most of you are familiar with Crosssite scripting, but I will quickly recap. So Crosssite scripting is a vulnerability that lets the attacker execute any kind of code, any kind of code in the context of our web page, right? And what does it really mean? It does mean that attacker is able to steal cookies, steal local storage data. Basically, the attackers are able to do anything we would do as programmers in the context of our web page. And if you want to learn more about cross-site scripting, there is this great resource called OWASP, because there are many kinds of cross-site scripting attacks. There are many techniques to defend ourselves against the cross-site scripting attacks, so we should go to OWASP and learn about them. And I've prepared a demo, so I will show you how to do a cross-site scripting attack. So imagine we are an attacker, we are a hacker, and we want to hack into this blog, right? This is a blog, like, we have a blog post here. You can go and read it. And what would I do as a hacker to try to hack this blog? I would probably go and see, like, it's in WordPress, right? And try to hack it as it was WordPress. It turns out it's not in WordPress. And then I would look for more interesting parts, and I would go to something like this. Admin. Oh, well, there's an admin login, for example, and probably admin has some, there is probably an admin panel that would be interesting from an attacker's standpoint, and our goal right now is to hack into this panel. It happens that I know the login password. Whoa. I will just show you what's in panel. Yeah, it sounds like this. And our intention would be to hack into this panel without knowing any kind of password or login, any kind of credentials. So what could I do? As an attacker, I would go to the website I would like to hack, and I would look for possible input points. Like, for example, let's go to the post, because posts usually have a comment section. And it turns out that there is this comment section. And what we can do is we can try to put some HTML here. Whoa. Something broke. Sorry. Unhandled error. Yeah, demo guts, right? Yeah, let's start it. Once again. Oh, sorry. We would just have to It just worked. It worked like 5 minutes ago, so. Demo guts, right? Yeah, let's do this one more time. Post, yeah. Yeah, the restart is always a good thing. Yeah, and it works. And as you can see, I've typed it, I typed there a bold tag, right? And as we can see, the browser read it as HTML and execute it. So what I can do is I can try to put a script tag there and see what happens, right? And as you can see, the script got executed. That's all right. So that's my security vulnerability that I can abuse. And right now, I would assume that the session is stored in cookies. I would use this hole to steal the cookies. And my code for stealing cookies would look something like this. Here's my code. It's called hack. Yeah. Yeah. Is it readable from the back? Or, yeah. So basically, what I want to do is I want to get my cookies and send them to my server, so then I can, somehow get them and log in into the admin panel, assuming that the admin of the web page would eventually go to the post and try to read it, right? So that's my script, and I would just add an image tag to my web page and add the special get parameters. The image wouldn't load, but I still get a request and in this cookie parameter, I would get encoded cookies, right? And that's great. So if we post it, yeah, great. Oh, my server is down, but no worries. Yeah, right. So right now, as you can see, it says only great article, thanks. But it tries to send some cookie to my server, which it didn't because the server wasn't running, but when I refresh, it probably will. Yeah, and it did. Because I'm already logged in as an admin. You see, I got the request here, and this encoded thing is my cookie. So now when I copy this and open a new separate window, as you can see, I'm not logged in, but when I try to set my cookie here, I've prepared a little snippet. No, not here, but here. And if I add my cookies, yeah, it just set the cookies in my current browser window. And if I go to admin panel, I'm logged in, right? And I didn't know any passwords because it's like completely separate page. So the attack went like this. I just found a security cross-site scripting hole. Then I planted the script that stole every cookie from the website. And then I used those cookies to get into the admin panel. So that's pretty scary. And let's go back to the slides. So, yeah. And I know that this demo was a little bit exaggerated because normally you would use something which is called HTTP-only cookies, that I wouldn't be able to read them. If you want to keep the session in cookies, you should use HTTP-only cookies. But I disabled this feature for a purpose because I wanted to show that it's really easy to steal some malicious data from the user, some personal data from the user, and then abuse it somehow. And how to be safe. So one might say that I should always filter the input from my users and use sanitizer, so and strip every HTML tag that is posted to the comments section. And that's true, but it turns out that those parsers could have bugs, and there are really, really sophisticated bugs, but still, there are bugs. And on the other hand, there is a better way of protecting ourselves against those kinds of attacks. And this method is called content security policy. And content security policy is nothing more than a whitelist, which lets us define the URLs from which our browser is allowed to download some resources. So for example, I can tell, hey browser, you are allowed to download stuff from Bootstrap and from Facebook, but you're forbidden to download anything from different resources, right? And not only content security policy lets us define what we can download, it also lets us define how do we want our scripts to be executed. So for example, we can say that we can execute the scripts using we can allow the browser to run the scripts added using source attribute like this, and we can say we don't like inline scripts, so we want to disband them, and browser wouldn't even execute this code. And content security policy is turned on using HTTP headers. We just specify on our server, we specify the content security policy header, which look like this. It's here we have header, content security policy. Then we have something called directive. In this case, it's script. It defines from which resources we can download scripts. And there is a URL list which says we can execute scripts from and download scripts from self, which is our domain, and from Google. Yeah? As simple as that. So having this knowledge, we can try to fix our demo so the attack I presented you wouldn't be even possible. All right. So here's my server code, and it's like really basic really basic Express app, which uses this really neat package called Content Security Policy. And here are my content security policy rules. There are a couple of them. I'm specifying the resources that my page uses. So I can use only scripts from source self. And there is a couple of things I've added here because my web page requires Bootstrap and some Google fonts, right? So when I use this middleware, and restart my server, and go back to my web page, I would have to, And as you can see, my browser refused to apply inline, it's inline script, actually. And this, sorry, yeah. So it's here. All right, so as you can see, my script didn't get executed because it refused my content security policy, which says that I can only download scripts which are from my own domain. And not only did it block my inline script, which is not explicitly defined in my content security policy rules, it also gave me this nice report here that says that somebody tried to hack into my web page, and we can specify the content security policy rule to send this report to our backend, and then we can filter those reports and see that somebody tried to hack us. And that's really neat, and as far as I know, the Sentry, the tool for getting logs, is also supporting content security policy right now, so you can definitely check it out and see whether somebody tries to hack your web page. So right now, my attack would be completely impossible because the script we planted before is not executing, and that's great. Sorry. All right. So as I said before, content security policy lets you define many different rules for resources, and we can control almost everything. Like we can control the WebSockets. We can specify to which servers WebSockets are allowed to connect. We can specify the image resources. As you can see, the astronaut photo didn't load because I didn't explicitly tell the browser to load it, right? And content security policy is really, really great, but it also has its downsides. Just look at this. It's the content security policy header from Gmail, right? And there is a lot of stuff here, and it's really, really hard to maintain those rules because imagine you are using third-party scripts like analytics scripts or Google Tag Manager or something that we have a tag manager that downloads many different resources from many different domains, and we don't even know from which domains we load content to our web page. And to make them work, we'll have to explicitly define them in those rules, right? Because otherwise they won't be working. And as you can see, this gets pretty large, and it hits both performance because we had to load this header. And if we have that many rules, probably we are not safe anyway, because if some of the different services that we listed here get hacked, we would be affected as well. So that's really hard. And if you try to use content security policy right away, your web page would probably break, because it's really, really hard to know the exact resources that your web page uses. And there will be, if you turn on the content security policy today, you will be surprised how many of things your web page downloads, right? But so there is one rule: if you start a project, start using content security policy as soon as possible, because it will give you the full control over your resources. Another downside is that, I am building single-page applications, and we use Webpack for building our own, the application itself, and we end up with a package that is completely serverless. We don't need any servers. We just want to deploy those 3 files, and we decided to use Amazon S3, right? Because it's like common use case. We just put those files on S3, turned on static website hosting, and we are done, basically. And it turns out that Amazon S3 lets us define our own headers. So that's great, because we can use it to control cache, and we thought that it would be nice that we would be able to add content security policy here. So we would get an architecture that is that has no moving parts. We wouldn't have to maintain any servers, anything. And it turned out, when we turned the CDN before, ahead of S3, it turned out that S3 doesn't support content security policy headers for some reason. We don't know why. So we had to add an Nginx before our Amazon S3 just to add those headers. And that's the another downside of the content security policy is that only a few hosting providers and CDN support those headers. I don't know really why. If you ask them nicely, they would probably turn them on for you, but it's not by default. And it's it's really, really hard. And to sum up, what have we learned today? Yeah, we recapped what cross-site scripting was. We learned what content security policy is, and the most important thing that I would like you to learn from my talk is that security is really, really hard, and we should always pay attention to it because it's really important, and it can cost us a lot of money and and it can cause a lot of trouble if we don't have security done right. And here are a couple of links you can read afterwards. And my name is Kacper Sokołowski. Go follow me on Twitter, and thank you very much.